in this unit, we are going to be looking at similar figures. If you remember back to Unit 3, okay, two figures are congruent if the second figure can be obtained from the first figure by a series of reflections, rotations, and translations. Okay. If you remember, for two figures to be congruent, they need to have the same size and shape. They must look exactly the same. Nothing can change about the size or the shape. Okay. So, take a second before I go on. Pause the video if you would like. Okay. To get between our first image here, BCOK, down here, all right, we need to figure out a transformation or sequence that we can map it right on top of the other image. So first, what I'm going to do is I'm going to reflect it over the y-axis. Okay. Remember, whenever we are doing a reflection, it will be a mirror image just on the other side. Our two easiest points are going to be K and O right here. K prime, O prime. Because they are directly on the line that we were reflecting over. They aren't going to move anywhere. B here is 5 to the right. 1, 2, 3, 4, 5. So we need to go 5 to the left. 1, 2, 3, 4, 5. There's B prime. And then C is 3 to the right. So 1, 2, 3. We got to go 3 to the left. 1, 2, 3. The image that we have just created from this reflection now looks like this. So, these look like they're going to line up now. We just need to shift it down somehow. Well, the way that we do that is we can translate down from this point down to the bottom. Let's count. We got to go all the way down to 8, right? Yeah, -7, -8. So, translate down 8 units. Okay. So, if we go down 8 units from each spot, we will end up directly on top of this shape down here. Now, for our congruence statement, remember, corresponding parts must line up. Okay. So, BCOK, where does B end up? Well, B goes to H. C goes to Q. O goes to P. And K goes to Y. So remember, each of these angles are going to be congruent to each other, and we have to write them accordingly. Okay. The new thing for 9-1, okay, two figures are similar if they have the same shape but are different sizes. Okay. Same shape but different size. If you think back to Unit 5 with our proofs, okay, an example of this would be our angle-angle-angle relationships. We said that we cannot prove congruence with those, but if we look back, we could have actually showed that those shapes were similar. Okay. So, like with our congruent shapes, two figures are similar if the second figure can be obtained from the first figure by a series of translations, rotations, reflections, and the new one, the only transformation that we had that changed the size, dilations. Okay. When we are describing a dilation, we need to make sure to include the scale factor. Remember, the scale factor is the number that we multiply by, which is how much it's going to grow or shrink by. So if it's going to be greater than 1, it's going to grow. If our scale factor is less than 1, greater than 0, it's going to shrink. Okay. We also need to include the center of dilation. Okay. So, let's go ahead and take a look at our example here. our first question is, are the figures congruent or similar? Well, if we look at the shapes here, they look to be the same shape, but they're definitely different sizes. So these are going to be similar triangles. Okay. Take a second, pause the video, and I would like you to try and describe a series of transformations that proves that the figures are similar and congruent. I'm about to get started. So, start with triangle LKO. That is a small triangle here. Okay. First, we're going to need to get it to be rotated so that it'll line up with our new triangle. So what I'm going to do is I'm going to rotate 90 degrees. I want to go to the right, so I want to go clockwise. And where am I going to rotate around? The origin. Okay, 90 degrees clockwise around the origin. Okay, so remember, 90 degrees represents one turn of your paper. Okay, and then we're going to see where we need to go. For example, O is going to stay in the same spot. Turn our paper, one turn represents 90 degrees. To get to K, we got to go 1, 2, 3 to the right. We put our paper back to normal. We're going to go 1, 2, 3 to the right. So there is K prime. Our final point, rotate one time, 90 degrees. Then to get to L, we go 1, 2, 3, 4 up. 1, 2, 3 to the right. So we're going to go 4 up and 1, 2, 3 to the right here. Now, our triangle right here, this will be L prime, O prime. Okay. Remember that when we map a pre-image to an image, alright, the second one that we create, we're going to name it with these primes. Okay, so L prime, K prime, O prime will be our new triangle. Okay. Now, I need to figure out how big do I need to increase by to make this triangle match up with the larger one. So let's look. From O to K here, we go 1, 2, 3 units. Okay, we go 3 units. However, from O to C, we go 6. So from the small to the large, okay, if we divide by 3, our K is going to equal 2. Okay, so K is our scale factor. K is our scale factor. So I'm going to dilate by a scale factor of 2 about the center (0, 0). How do I know the center is 0, 0? Remember that if we connect our image and pre-image together, okay, so if I were to draw a line here, wherever they all intersect at will be the center. So going through here and going through here, and then obviously O is right on the origin. Okay, so they all pass through at 0, 0. So if I multiply this by 2, okay, O is going to be in the same spot. O to K is 3, so I'm going to go 3, and then I'm going to go 6. I end up in the right spot. To get to L, I got to go up 4 over 3. So if I multiply that by 2, I got to go up 8 over 6. We land right on top of B. We've now made our new image, and we are good. Okay. What do we need to name our second shape? Well, it has to line up with LKO. Okay, just the same as it did above. So, L ends up on top of B, K ends on top of C, and O is still O. Okay. And these triangles, they're not congruent, they're not the same shape and same size, but they are the same shape, different sizes. So these are similar. Okay. So we mark it with a little tilde. Okay. So what this would read as, if you're saying it out loud, you would say is similar to. It's the same as our congruent sign or our equal sign. We would say is congruent to or is equal to. Okay, this is similar to. Okay. All right. There are two things that will always happen if polygons are similar. Okay? If two polygons are similar, then corresponding sides are proportional. When you think of the word proportional, what do you think of? Talk to the people around you. Okay? In the proportion of the scale factor. Okay? So, what that means is the polygons are going to grow or shrink at the same proportion, at the same ratio, no matter what. Okay? Corresponding angles are congruent. Okay? So all the angles will still line up. The shapes will just be different sizes. Okay? The reason that this will work is because when we dilate it, it doesn't change the size of the angles, it just changes the size of the whole shape. And it does it proportionally. Okay? Pause the video and try to describe a series of transformations that shows Hij is similar to KRTY. Okay? I'm going to start right now. Okay. What I'm going to do is I'm going to try to find how much I need to shrink down by. So, I could find any of these distances, okay, and compare them between the two images and find out what the ratio is. What I'm going to do is I'm going to count from H down to J because it goes right down this line, okay, and it looks like it's going to be the easiest one to count without actually having to calculate any sort of Pythagorean theorem or distance formula. So, I'm going to go down from H down to the origin. It's going to be 8, 9, 10, 11, 12. Okay, so this whole distance here is 12. Now, let's look at the same thing in the smaller triangle. In the smaller shape. So, K down to T, we go down 1, 2, 3, 4, 5, 6. Okay, so this is 6. So, we're going from 12 down to 6. Okay, what do we need to multiply by? Well, that'll tell us that our scale factor is a half. Okay, so we're shrinking it down by a half. So we're going to dilate our shape, Hij by a scale factor of 1/2 around center 0, 0. Okay. So I'm just going to do it directly around this origin. I'm going to make it smaller, and then I'm going to make my shift. Okay. So if I'm taking half of everything, I just need to go halfway up. So from the origin to H is 8, so I got to go up 4. So here is my H prime. To I is 4, so I got to go 2. To G is 6, so I got to go 3. And from O to J is going to be 4, so I got to go 1, 2. Okay. Again, remember we name it with all the primes so we can tell the difference between where we started and where we went. Okay, there's our new shape. Now I need to move this down and I need to move it over so it ends up on top of it. So I'm going to look at this bottom point because I can see that it makes this kind of shape here, and I want it to line up with that shape down here. So to go from J prime down to T, how far do we got to go? Well, we got to go down 1, 2, 3, 4, 5, 6, and then we got to go right 1, 2, 3, 4, 5. So we're going to translate down 6 units, right 5 units. Okay, so we're going to do that from each spot, and we should end up right on top of our image. So J prime down 6 over 5, I prime down 6, so 0 down to negative 6 over 5. 1, 2, 3, 4, 5 ends up here. Okay, down 6 over 5, down 6 over 5. It maps directly onto this image here. Okay. Next, we need to write a congruence or similarity statement. Okay. So Hij is how we decided to name it at the beginning. Okay. It's going to be similar because we know that we had to change the size of it to get it to match up. but they still have the same angles, okay? And it was proportionally